Okay, in this video, we are going to learn about something called a piecewise function, and then we're going to learn about a specific type of piecewise function, which is called a step function. So first thing we need to do is learn some definitions. Okay, a piecewise function is one which is defined not by a single equation, but by two or more. And each equation is valid for some interval over the domain. Okay, and I'm going to show you what I mean in a second. A step function is a piecewise defined function, so it's a type of piecewise function in which every piece is a horizontal line segment. Okay, so it kind of looks like steps. Imagine horizontal line segments stepping up. Let's take a look. Okay, so here's a piecewise function. I'm going to graph it, and then we're going to talk about what it means. So we have some function, f of x. For all the values where x is less than 0, so for that domain where x is less than 0, we're going to graph x plus 2. Okay, so what I'm going to do is I'm going to just graph the graph x plus 2. So I go up to 2, and my slope would be up 1 over 1, up 1 over 1, right? Down 1 over 1, down 1 over 1. And you can imagine that it would be this entire line here. Point there is bad. Okay, so it basically would look like that, but it's only defined for where x is less than 0. So I need to erase this. So x is less than 0 to the left of the y-axis, so it's going to look like that with an arrow. Okay, just that part. This should have erased. Now, for where x is between 0 and 1 inclusive, we need to have the line y equals 2, so it's right here. Now, see how this was x is less than 0? This should have been an open circle because it doesn't include that value. But now it's going to be this line between 0 and 1, and it includes those values, so they're solid dots. Okay. Now, for the values where x is greater than 1, we're going to have the line negative x plus 3. So I'm going to go to 3. And I have a negative slope, down 1 over 1, down 1 over 1, down 1 over 1. So it's going to look like this. And that would have had an open circle, but because it's closed, because of that part, we'd go ahead and it's closed. Okay, so if you were asked to evaluate f of 2, for instance, f of 2, we go to where 2 is, and the output is 1. If you were asked to evaluate f of negative 3, it would be right here. So it would be negative 1. You could also plug it into the values. You'd say, okay, well, when x is negative 3, that's this part of the piecewise function. So I'd plug negative 3 in there. Negative 3 plus 2 is negative 1. All right, so there's piecewise. Okay, so now these are step functions. So it says the function f of x is equal to negative 3 for the interval negative 4 to 1, inclusive of 1. And f of x is 2 when x is greater than 1 or less than or equal to 3. Okay, so when we're at negative 4 to 1, 1, 2, 3, here's negative 4 to 1, negative 4 to 1, we have the graph y equals negative 3. So here's negative 3. And this is our graph. Now, open or closed circle. When x is greater than negative 4, so we have an open circle here, less than or equal to 1, closed circle. Okay. And then when x is between 1 and 3, we graph the line y equals 2. So here's 2. So we're going from here to here. X is greater than 1, so we have an open circle. And less than or equal to 3, closed circle. So if you were asked, what is the value of f of 1? Well, it's not 2, it's negative 3. If you were asked f of 0, oh, negative 3. Okay. All right, so let's take a look at a type of problem that would ask you to actually evaluate step functions. So this is our function. Okay. Find f of 4.1. 1, 2, 3, 4.1 would be like right here. So the value is 4. The output is 4. F of 4. 4, uh-oh. That is undefined. Open circles where x is 4. Okay, there is no value for this function there. F of 0.9, so here's 0.9, so it looks like we're down here, so that's 1, 2, 3, negative 3. F of negative 1.75, there's negative 1, negative 2, negative 1.75 would be right here, so that's negative 3. Okay, good luck.